Good morning, students. So let's start with the next topic, advantages and disadvantages of algorithms. So in the previous lecture, we have studied about algorithm. So what is algorithm? Algorithm is step-by-step representation of any process. Now the next thing is we have to study why we are using algorithms, what are the advantages and disadvantages. So the very first advantage of using algorithm is it is step-wise representation of a solution to a given problem, which makes it easy to understand. So if we make use of algorithm, it is easy for the user to understand the concept because we have to write algorithm in any of the simple language instead of any programming language. Next is an algorithm uses a definite procedure. So if anyone has to write algorithm, he has to follow the proper rules while writing the algorithm. Next is it is not dependent on any of the programming language. As I have already discussed, anyone do not have to make use of any of the programming language. Anyone can write it in any of the language. So it is easy to understand for anyone even without any programming knowledge. Next advantage of using algorithm is every step in an algorithm has its own logical sequence, so it is easy to debug. Debug means how we have to find the errors. So if the algorithm is in simple language and it is easy for the user to understand, then obviously it is very easy to debug and to find the errors. If the algorithm is in programming language, then it is quite complex for anyone to find the errors. So that's why it is very easy to debug errors if the algorithm is in simple language. Next advantage is by using algorithm, the problem is broken down into smaller pieces. Hence, it is easy for the programmer to convert it into actual programming. Students, this concept is known as modular approach. Now, what is modular approach? Modular approach is we can divide the large problem into small problems and we can work on small pieces or small problems, and it is easy for anyone, even it is easy for the programmer to convert it into actual program, to find the errors, to debug the errors and even to test the program. So modular approach is very good approach whenever anyone has to work with programming. So these all are the advantages of algorithms. Now the next topic is disadvantages of algorithm. What are the disadvantages? The very first disadvantage is algorithm is time consuming process. No doubt it is easy, or it makes it easier for the user to understand the concept, but programmer or the second party which is preparing for the software, they have to spend extra time to prepare algorithms. So that's why it is a time consuming process. Next is it is difficult to show branching and looping in algorithms. Branching and looping means, see students, as I have told you that whenever we have to write algorithm, we can use simple English language or any other language instead of programming language. But in programming language, we have to make use of some loops and conditions. So it is difficult to write these conditions or these looping statements by using algorithm. So it is a bit difficult process to represent branching and looping statements. Last disadvantage of using algorithm is big tasks are difficult to put in algorithm. So if the program is of 100 lines and if the program is of 200 lines, in that case it is very difficult to write algorithm of that program. So sometimes it is very complex task to write algorithms of complex or lengthy programs. So these all are the disadvantages of algorithms. So with this we have completed the second topic of this unit, algorithms. and I hope it is clear to you why we have used algorithm, because we have studied system development life cycle. System development life cycle means whenever anyone has to develop any software, he must have to follow all these steps. And in the second phase of system development or program development life cycle, that is program design, when anyone has to design the program, the programmer has to make use of algorithms and flowcharts. So with this we have completed this topic algorithm. Now we have to start next topic, that is flowchart. So let's move to next topic, flowchart. So what is flowchart and why we use flowchart? Flowchart is a diagrammatically representation of the workflow or a process. So see students, as in the algorithm, we have studied that whenever anyone has to develop any program, then before developing the program, the programmer can write algorithm of that program so that it is easy for the user to understand the concept. Now next thing is flowchart. Flowchart is when we convert, or flowchart provides us facility that we can convert the algorithm into pictorial form. We can convert the algorithm into pictorial form, as in we can make diagram of the whole process, and it is quite easy for the user to understand the diagram. So flowchart is a type of diagram that represents a process. Flowchart can also be defined as a diagrammatic representation of an algorithm, because it is also a step-by-step approach to solve a specific task. So for example, if user has to develop a program, and whatever he wants to write in the program, he can simply make a flowchart to represent the step-by-step approach. So that is flowchart. Now, what are the different symbols that we have to use in the flowchart while representing different things, and how we can solve a task by using flowchart? So the flowchart shows the steps as boxes of various kinds. Different types of boxes are available, and every box has its own use and own shape. So you must know that what is the use of every box and how we have to use any of the symbol while writing or while drawing flowchart. So in flowchart you have to make use of different types of boxes and their order by connecting and you also have to connect these boxes with arrows. So the diagrammatic representation indicates a solution model to a given problem. Now, flowcharts are also used in analyzing the problem, designing the problem, documenting or managing a process or program in various fields. Nowadays, each and every field is making use of flowcharts because it is easy for the programmer to represent the complete process by using flowchart to the client. So let's start with the symbols or the boxes that we have to make use in the flowchart, and where and how we have to use specific symbol. So the very first symbol is, the name of this symbol is terminal symbol. This is oval shaped symbol, and when we have to use this symbol, we always have to use this symbol while the starting or stop and the halt in a program's logic flow. Whenever you have to start a program, stop a program, or halt means when we have to forcefully stop the situation. So that is halt situation. So start, stop and halt can be indicated by a terminal symbol. So in every flow chart, terminal is the first and last symbol in a flow chart. Next symbol is parallelogram symbol. Now, when you have to make use of this symbol, whenever you have to give any input output, you have to make use of this symbol. So we also call it as input output symbol. So this symbol denotes any function of the input-output type. Program instructions that take input from the input device and display output on the output device are always indicated with the parallelogram in a flowchart. So see students, when you have to receive any input or you have to provide any output, you have to represent input output statements always in the parallelogram. Next symbol is rectangle symbol. Now when you have to make use of this symbol, we also call it as processing box. Now why it is known as processing box? A box represents arithmetic instructions. Arithmetic instruction means arithmetic always means whenever you have to perform addition, subtraction, multiplication, division. So we also call it as expression. So whenever you have to write any expression, so that's why we call it as processing. Expression means, for example, I want to perform sum of two numbers, that is a plus b, and I want to transfer the result into third variable c. So that is processing. So whenever we have to write any of the expression, we have to make use of processing box. So this box represents arithmetic instructions. All the arithmetic processes such as addition, subtraction, multiplication, division are indicated by action or process symbol. So this box is also known as action symbol. Action means because we have performed the expression or we have performed the action. Next symbol is diamond symbol. Now how we have to use and when we have to make use of diamond symbol. This box is also known as decision box. Now why this is known as decision box? Because whenever we have to take any decision, we have to make use of this box. Now let's talk in programming language. If we talk about programming language, we have different statements. We have different conditional statements which we can use to which we can use in whenever we have to take decisions. So these conditional statements are if statement, if else statement. So these all are the when we will start third unit, then I will explain you all the conditional statements of the programming language. So whenever we have to apply any of the condition by using any of the conditional statement, we have to make use of this diamond box, that is decision box. So diamond symbol represents a decision point. Decision is always based on the operations such as yes or no questions, true or false conditions, which are always indicated by a diamond box in a flowchart. Next symbol is connectors. Now why we have to make use of connectors? Whenever flowchart becomes complex or it spreads over more than one page, so it is always useful to make use of connectors to avoid any type of confusion. So it is represented by a circle. Next is arrow. Different types of arrows are available in flowchart and we also call it as flow lines. Now why it is known as flow lines? Because flow lines indicate the exact sequence in which the instructions are executed. So if we have a downwards flow line, it indicates that we are moving from top to bottom. So arrows are used to indicate the flow or direction of flow in a flow chart. Arrows always represent the direction of flow of control. Flow of control means now if we are at second step, then how we have to move to the third step. So that is flow of control. And it also represents relationship among different symbols of flow chart. So flow lines are very important and different flow lines are available. Now I have taken one example of a flow chart. So I will show you that how you have to make use of different symbols while designing a flow chart. So this is, I have taken a problem that we have to display the result of a student, and if the marks are greater than 50, then you have to display the result as a pass, and if marks are less than 50, then you have to display the result as a fail. So this is the problem. Now we have to design a flow chart according to the problem. So let's start with this. The very first, in every flow chart you always have to make use of this start symbol. So start is used to indicate the start of the flow chart. So this is terminal symbol. So the very first symbol is start the flow chart. Now next is parallelogram. So in parallelogram you have to enter the marks, whatever marks you want to enter. For example, a student has secured 40 marks, so you have to write marks in this parallelogram. Now you have to apply the condition. Why we have to apply the condition? We have to apply the condition to check whether the student is pass or fail. So whenever we have to apply the condition, we always have to make use of diamond symbol. So this is diamond symbol. Now we have to apply the condition. Condition is marks greater than 50. So if marks greater than 50, then it will execute this box. This is yes. If marks greater than 50, then it will move. See here I have used this arrow to indicate the direction of flow. It means we have to move from this place to this place. Now if the marks greater than 50, you have to display the result as pass. So display result as a pass. So you have to write this in parallelogram, because this is a expression. We are representing, or we are presenting the result of a student as pass. Now the second condition is if marks less than 50, you have to display the result as a fail. Now this is again a arrow to indicate that where we have to move. Now we have to move to the right hand side of this condition, and here we have used parallelogram to display the result as fail. So see students, in this condition box we have applied two conditions, yes or no. If the condition is yes, it will execute this block. If the condition is false, then it will execute this block. It will execute only one block at once. Now if the result is pass, then it will move from this place to this place. So here is an arrow, and this is end of the flow chart. Now if the student is pass, then the control will flow from this location to this location, and if the student is fail, then it will not execute this part. Then the control will flow from this location to this location. It will display the result as fail, and then it will move to the end of the flow chart. So it is very easy, and it is very important for you to understand that how you have to draw the flow chart, because in 12th standard also, whenever we study programming language, or whenever we have to prepare journals, we always have to draw flow charts of the programs. So try to make some flow charts at your own site. You can take a simple problem and then you can try flow chart of that particular problem. Now I have taken one more example of a flow chart, sum of two numbers. So for example, we have to perform sum of two numbers, and we have to display the result of two numbers. So let's talk about algorithm. If we have to write algorithm of sum of two numbers, then what we have to do is we have to start the algorithm. Then in the second step, we have to read the value of two variables. Let's suppose the name of two variables are A and B, and we want to transfer the result into third variable. The name of the third variable is sum. So look at this part, right hand side part. So let's consider it as an algorithm. So start with this first step, read the value of A and B, and then perform addition of two numbers and transfer the result into third variable sum and display the sum, and after this end of the algorithm. So let's suppose this is the algorithm and we have to convert it into flow chart. So let's start with how we have to convert it into flowchart. So the very first symbol is start. It indicates the start of the flowchart. Now the next step is read the value of A. So for this you have to make use of parallelogram, because this is an expression we are reading, or I have already told you that whenever you have to perform any input output operation, you have to make use of parallelogram. So when we read the value of A, so this is we are getting the input. So that's why we have to make use of parallelogram. So read the value of A, read the value of B. Now here I have taken two different parallelograms. Now it is up to you and it is up to the user. They can also make use of one single parallelogram and they can write read A comma B also. So it is up to the user. They can make flowchart we can make flowchart in different ways by using symbols. So after reading the value of A and B, the third step is you have to perform addition of two numbers. So when you have to perform addition of two numbers, it means you have to perform arithmetic operation, and this is expression. So whenever you have to make use of expression, you have to use this rectangle box, because this is a processing box. So A plus B, and it will transfer the result into third variable sum. Now the answer is in sum variable. Now you have to print the sum. So next statement is print sum. This statement will print the sum of two numbers and end of the flowchart. So this is the end of the flowchart. So I hope it is clear to you that how we have to make use of different symbols while designing flowchart, and you can construct different flowcharts of a single problem also. Now let's start with next topic, advantages and disadvantages of flowchart. So let's start with advantages. Why? What are the advantages if we make use of flowcharts? Flowcharts are the better way of communicating the logic of the system. So why it is better way? Because it is very easy for the programmer and easy for the user to understand the idea and the logic of the program. Next is flowcharts act as a guide for blueprint during program design. Flowcharts help in debugging process. Again, it is very helpful whenever we have to find errors. With the help of flowcharts, programs can be easily analyzed. It is very easy for both for the programmer and for the user to analyze the programs with the help of flowchart. Why it is very easy to analyze the programs? Because everything is in pictorial form. Next is it provides better documentation, and flowcharts serve as a good proper documentation. So these all are the advantages of flowchart. Now what are the disadvantages of flowchart? It is difficult to draw flowchart for large and complex programs. So as we have already discussed it in case of algorithms, if the program is very complex and if the program is very large, then it is very difficult to design algorithm of that program. Similarly, it is also difficult to draw flowchart of that program. So in this, there is no standard to determine the amount of detail. So this is the main drawback of flowchart. There is no standard to determine the amount of detail. It means we are presenting only the overview. There is no detail. There is no detailed information that we can present in flowchart. So it is just pictorial representation. So this is actual drawback of flowchart. It is difficult to reproduce the flowcharts. This is another disadvantage, and it is very difficult to modify the flowchart. This is one more disadvantage of flowchart. So these all are the advantages and disadvantages of flowcharts. Now, this is the last topic of this session. Here I have taken an example of algorithm, flowchart and program, and how they are interrelated, and how we can develop a program by using algorithms and flowcharts. So I have taken example of if we have to find sum of two numbers, then what will be the process that we have to follow. So first of all, the very first step is we have to write algorithm. So this is the first step. Start, read the value of a and b, perform addition of two numbers and transfer the result into third variable, that is c, and display the value of c. Print or display, you can make use of any of the term. Print or display the value of c and stop. So this is simple algorithm. Now the next step is you have to convert the algorithm into flowchart. So this is start, read the value of a comma b. This is expression a plus b is equals to c, and write the value of c, display the value of c. This is another parallelogram, because this is input parallelogram and this is output parallelogram, and stop. Now this is program, how we have to convert this flowchart into program. So this is program. You don't have to study this program, this is just an example. So this is how we can convert algorithm flowchart into program. So with this we have completed this topic, that is algorithms and flowcharts. Tomorrow we will start with the next topic of this unit. So that's all for today.